week I have just given a background, right? What exactly it is all about, and this time we'll start with like how it works internally, and then we'll see the other stuff. By the way, Manoj, your bias and variance trade-off is clear, or you want me to explain it in next five
If you
minutes?
can explain, that would be nice. Anyway, it's moderately clear, yeah. But if you can explain, that would be nice, yeah.
Okay, so I'll just take 5 to 10 minutes to explain that, and then we'll move on. Okay, let me share my screen.
Yeah, sure.
So, what do you know? Can you tell me like what you guys know about and why we use this? What is the purpose of having this bias variance?
Yeah, my understanding about the variance in this scenario of overfitting is that for the repeated test, what is the difference in the value of the predicted and actual? Sorry, for the predicted, yeah, difference in the value of the predicted for each test.
What does it mean?
So we are conducting the model is once trained and then we are
Mm-hmm.
testing it, right? So
Mm-hmm.
when you do the test,
Mm-hmm.
we got a particular value of the predicted value, right?
Mm-hmm.
And then again you do a test and you get a different predicted value, and again you do a test with a different set of inputs, you get a different value of the predicted. And what is the difference between this scattering of this values?
No, 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 no. It's wrong. It's okay. So let me give you just a brief, maybe 10 to 15 minutes. I'll take this. Basically, there are two terms used in machine learning world. Okay,
Mhm.
overfitting and underfitting. Okay. So what happens in overfitting is your model is trained well with the training data. Okay,
Yeah.
but it's not performing well with the test data or prediction data. That's your overfitting.
Hmm.
You got it?
Yeah.
Like you created a model using some data. It has learned all the patterns in the data. Now it is going to do excellent with the training data. Okay, means you may got get accuracy of let's say 98%, 99%. You will think my model is awesome. But when it comes to prediction, your model accuracy is let's say 70% or 65%, right? So it means it is not predicting that much good compared to what it was doing in training data, is called overfitting. So this happened with a lot of models. One of the example is your decision tree. Why it happened? Because it tried to go till until its complete depth. Okay, and it will try to uh, you know understand and get the training from each data point, and that's where it learns noises also along with the data, and that's why it happened. So this is your overfitting. Underfitting is just a opposite of this. Basically, a model which does not perform well in the training phase as well as it does not perform in the test phase, because a model when it does not perform well in the training phase, definitely it is not going to perform good with the test data also. So that's what the underfitting comes. Okay, what is our target? Our target is that our model should be generic. It should not have a overfitting case also and underfitting case also. Can anyone tell me any algorithm names which takes care of both?
Lasso.
SVM.
Okay, Lasso is definitely it's the regularization of basically L2 regularization, right? Sorry, L1 regularization. So region lasso is the one. So apart from, you can see if you see any ensemble modeling techniques, right? Like ADA boost, XGBoost, gradient boosting, right? These also take care of this basically. Okay, so automatically, because it internally takes the base models, to avoid the issue of this overfitting or underfitting, I can say. Now you know what is overfitting and underfitting. So let's see this. Basically, when you talk about bias, right? Bias happens with the training data. Okay, so you see this definition, this technical definition written here: the inability of a machine learning model to truly capture the relationship in the training data. So basically, if I say that there is a bias, the model is biased, means bias means it is related with your training data. Variance related with your test data. Okay, so these two terms you have to make up your mind with these two terms, that when we are talking about bias, it is for training data, and when we are talking about variance, it is about test data. Now, let's say for this use case, so this star, this cross is right, cross is your training data set, and these dots are for test data sets. Okay, so if I create you can say a best fit line, okay, and if it is passing like this, straight line passing like this with few of the training data set. So what kind of, see, this is I have written anyhow, but just think and let me know, is it correct? This model is high bias and low variance. Do you understand this, Tom? Okay, so if you don't understand, basically you see that this line passes from few of the training data sets, like this one. It is near to this one. But if you see, there are many other data points like this or this. They are very far from the actual line. So this data set or this model is called high biased. High bias means it is basically having a biased. It's like a not. It is not good with the training data. Okay, so that's where this is called a high biased model. Low variance means this is your test data. So you see, compared to this star, right? This is near. So comparatively, it is having low bias, low variance. So if you see here, right, I have just mentioned clearly for training data, when the accuracy is good or high, okay, it's called low bias. So in this case, since training accuracy is not that good, that's why it's called high biased. And since testing accuracy is comparatively better, we call it as a low variance. I have created three graphs, this and this. Now you see this example of this one. This model, what it is trying to do, this it is trying to capture everything. See, it is a clear case of overfitting. Okay, so when there is a overfitting, definitely it's a low bias because it is trying to learn everything from the training data set. But see what happens with the test data, it is very far from the test data. See the differences. So if you take the differences of actual line and the predicted line, right? So actually is it this one, predicted is this one. So if you take the difference there, that's what the error is, right? That's what your loss or cost function we talk about, right, in the deep learning or linear regression. So it is high. So that's why even though this model is having low bias, means the training error is low, it's in this case it's definitely 0 point kind of 0. But you see the variance is very high, correct? The testing data is very far from the actual line. So this is also not a good model. What kind of model we generally look for? We look for a model like this, where we have low bias and low variance. So if you see carefully, right, this model is not passing with all the training data set, or it's not passing with the all the testing data set. But although it is very close to
Easy to shift complete luggage. Takes minimum a week.
shall I start?
Yeah, please.
Okay, so I was talking about this model basically, where we should have a model which is having a low bias and low variance, means there should be a generic model. Okay, it should not either pass from all the training data or it should not pass from all the testing data. So in this case, it is generic because even though the accuracy might be less, let's say 70% in the this case, because it is little far from this, but you see that accuracy of your test data also, right? It will be somewhere near maybe 68%, 65%, which is I can say kind of not as a good model, but training and testing accuracy will be similar, kind of similar. Okay. But in these cases, first and last is not that good. So that's how we define bias and variance, and it is used for underfitting and overfitting cases. To deal with these cases, right, underfitting and overfitting, we have three methods: regularization, bagging, and boost. In regularization, right, we have this ridge, lasso, and elastic net. These are three regularization parameters which we generally use. So what internally does, right, it will just add up some kind of penalty parameter. Okay. So that is a different topic altogether to discuss. So basically what happens that it it adds penalty if there is overfitting happening, right? It will stop that with the help of that penalty parameter. And then bagging and boosting, so this definitely uses the base models sequentially, or uh, maybe you can say one by one. Okay. So like output of one model is passed as an input to the other model. So these kind of models are, or maybe I can say, sequence and parallel is used, for handling this biased and this one variance issues. So any question?
So this variance is the difference between the predicted and the actual, or what? No, it's that's that bias.
Variance.
No, that's the bias,
So
right?
yeah, so bias is basically, you think it is like a, for the training data set, right? We use this term called bias. Okay, that when your training accuracy is good, we call as a low bias. When your training accuracy is not good, we call as a high bias. So bias is already or always associated with your training data. Okay.
Mm. Okay.
And variance is associated with your test data.
So when we test variance is the difference between the actual and predicted of the test data.
See, basically how you talk technically, let's say if somebody says, okay, that okay, this is a overfitting model is overfitting, okay, they will not say that low bias. It will be too technical, okay. So if they will say model is underfitting or overfitting, okay. So if they are saying model is overfitting, it means that what you should understand, it is having a low bias with but high variance. Because low bias means it is having low biased with the training data. Means it is giving very few errors with the training data. And
Mm-hmm.
what is this error? It's basically difference of your actual and predicted value. That's the error, right? In the terms of linear regression or these kind of models, correct?
Mm-hmm.
So let's say my model is, let's say the value is output value should be 90, okay, and my prediction is 98. Sorry, 89, okay. So the difference is very less, right? So I can say it's a low biased, correct? Because actually is 90, I'm predicting 89, but actually is 90 and predicting 50, so it's a high bias, right? Because here is a huge gap between actual and prediction. Okay.
What if the target is 90
Huh.
and my model keeps on predicting 78, 75, 76?
Hmm.
Will it be low bias, high variance?
So you have to see basically, you have to
Because I shared one image on this chat. This image helped me create
sh-
like
show me that image.
in the chat. I have shared that.
One second.
Why not, Parsoon, you share your and explain? I think it is an interesting image which you said. Why don't you talk about it?
Um,
Which image you're talking about?
um, in the chat, can you? Okay, you have shared one window, na? You have
Yes,
no
yes.
screen. That's why we cannot see it right now.
Maybe you can share. I'm stop sharing. Okay.
Okay. Okay. Sure. I can see, right? So I'll search for this. This
Mm,
image I saw in many places, maybe in book as well. I saw this, and this had me clarify most of my doubt which I had with bias variance trade-off. Earlier, we had these bias variance trade-off in books, right?
mm,
This I could not understand because this was completely dependent on data uh, with respect to some error. Okay, but
mm, mm,
this is like a dart board,
mm.
and I need to hit the bullseye, which is my target label.
Correct.
For
Mm,
say, for example, one sample in an entire data set, if I take just one single sample and I try to predict it, and all my predictions hit near about this, so I'll say it is low bias, low variance. If all my predictions hit around this, so how my predictions are made, like I have like 1000 data in my training set, and I have like 200 data for my test set. I had segregated like that. Okay, so when I trained my model, it trained well. It had maybe I checked the accuracy using the area under curve or maybe the confusion matrix, so it worked fine. The accuracy was like 78, 79%. So what it meant that it could classify like this. But when I'm using the same model and I'm trying to predict those labels, what I'll have here is this. What does it show? That yes, my model has learned. Okay, so it will try to take all the values and it will try to hit on a spot, and all those spots will be near about, but the target is far away. The error is
Oh, see,
big.
I'll tell you in simple term, maybe difficult for many to understand. See, simply to understand it, overfitting, underfitting, you guys know, right? That what is overfitting and underfitting. These terms are related with overfitting and underfitting. Now, if your model which you have created has learned everything about the data, okay, we say this model is having low bias because it has learned so many things from this data, and that's why it is getting overfitting issue. So generally it happens. You see normal. I'll give you a very layman example. Let's say if a person is expert, let's say he's a mathematician, he's expert in mathematics, so might be in math exams will score 98 out of 100. What about Hindi or English or let's say Kannada in Karnataka? Will he score same? Because he's more focusing on mathematics. So he may score somewhere around 60, 70, 80. That's all. He'll not score 98 definitely because there are exceptions. Is a human body, but I'm telling in general. Okay. So you think in that way that if some model is performing exceptionally well with the training data, accuracy is like 99%, 98%, but you should doubting this model, saying that this might be overfitting. If it is also performing same with the test data, then you should be okay. If it is 99% with the training and test both, then it's like a low bias, low variance. I should accept this model. So
But one thing,
model.
Anjali,
Hmm,
one thing I just
hmm,
want to.
yes,
This
please.
is very interesting, actually.
Hmm,
This figure,
hmm,
because it is only looking at the test, right?
hmm.
Prasoon, tell me if I'm wrong, right?
No, it
And
is
it is
showing both.
saying
No, it is showing both.
it is looking at
First,
training also. See, my
yes,
Both,
thing
both,
is
yeah.
yes,
See,
it
you
is.
have low variance, low high bias, and you can see that low variance, low bias, low variance, high variance, high bias, high variance, low variance.
no,
No,
in
So
the
it.
background, I understand. In the
sets.
Hmm,
background, it might have training also.
hmm,
But
Yes,
at the
you have
end, when
see.
you're talking about, your final results,
hmm,
okay, it is just telling me
hmm.
that when there is low variance and high bias, the thing is that the predictions are away from targeted, or the correct predictions, but they are bunched together. They are not spread out. They are missing the target, but they are not spread out.
Okay, I'll explain this. See what happens. This your red dot. PB, just correct me if I'm wrong. This red is your target, correct? The red
Correct.
inside is target, the bullseye which we are talking about.
Yeah.
Now, now if we say low bias and low variance, the first case, low bias on the columns and low bias in the row. Okay, so if we take this, it means the target is red one. Okay, and we are also predicting that. Okay, to use using this blue dots. Okay, so that is your low bias low variance, means model is doing well with the training data, as well it is doing good with the test data. I'm not saying it is 100% exactly same. Let's say accuracy was with the training is 98%, accuracy with the testing is with 95%, 96%, whatever, but it is very close. Okay, so that's the case of low bias and low variance, first one. If we talk about the second case, high bias, sorry, high variance, low bias. So this is your case of, tell me what case it is. Low bias and high variance. I just told
It's
this one.
underfit.
Overfitting, right? Overfitting. Low bias because your model has learned many things too much from the data, but it is not trying, not hitting this bullseye basically. See, it's not very close to the red one.
Got it. Got it. So you're saying that
Okay.
model has become very complicated. Low bias, high variance. I understand.
Yes. So see, model should be generic. Always the target is model should be generic. So whenever we create a model, right, always perform two things. Check the model. Generally, what we do as a newbie, we check the accuracy and we are happy. You should also check the accuracy of model with training and testing both. Because when we, let's say we create linear regression, right? Once we create the linear regression, we'll do the predict, like, right? That what is the prediction mean? So prediction means you are predicting with that the test. So we see that okay, 95%, 96%, but you also see what was the accuracy with the training and then compare. Is it nearby? If it is nearby, accept it. Otherwise, perform some other operations like maybe hyperparameter tuning or maybe feature engineering or maybe EDA, it's anything, okay, which helps you to get this low bias, low variance things. Okay,
You know
it is
what, Anjin and Prasoon, glad that you brought it out, and glad Prasoon you have brought it out that the figure in the left. Now I understand that figure completely because of this. This first
good.
figure in the left hand side, right, left top, which is the usual figure which comes up.
This
Yeah,
one.
yeah. Now I completely understand why it is there.
Mm. There is.
I mean, whatever you explained now, it completely makes sense, right?
Mm,
Go to the first figure now.
yeah.
See, go to the first figure, left hand side first figure, and why it is in the textbook. See, as the model is becoming complex, as it is, reducing, it is learning more and more. In the x-axis, see the model complexity, and it is increasing on the right hand side, right?
Yeah.
As it is learning more and more, its bias is getting reduced,
Mm,
right?
yeah.
But its bias after a point of time, when it has learned too much, it has
Mm,
become too exact, or probably it has learned even the noises from the training data set.
Yes,
when
yes,
when it gets applied to your test data set, your variance will increase, because in the test
yes.
data set, because it is noise, it might not be present, or the shape of the noise would be different in your test data set. So as your bias keep getting decreased, your value variance now will start increasing, because your model has become over complicated, and it has become overfitted.
mm,
Just you can again one layman example. Let's say we guys are mostly working in IT. Okay, we are few might be experts. Okay, if somebody will start asking history question with us, how will we perform? Or maybe some other question like statistics or like no, not stats. Maybe let's say Sanskrit something. Okay, so how will perform? It's same case. So basically, we are experts. So people, let's say who are joining this let's say government jobs, right? You see, right? They are not experts. Let's say if you talk about very elite exams, also they're not expert in any one field. They are like a generic. They know everything, but they're not expert. Okay, so that's why they score very I can say good in all the subjects, and they get that job because they're
mm,
not focusing to get the expertise like us or maybe the medical field side who wanted to get expertise on any one specific field.
mm. Correct.
So That's the whole idea, and it is tightly linked with your overfitting and underfitting. So just when somebody talk about this, right, overfitting, always think overfitting means low bias, high variance. Underfitting means it may be low biased, high variance, sorry, high bias, high variance, or high bias, low variance, anything. Okay. So generally we should be taking the model which is generic, which is having generally low bias and low variance. But it does not mean that if your model is, let's say, 65% in training and 63%, 64% in testing, you said like it's a low bias, low variance, low bias model, so I will accept it. No, because again, it is like not a good model, I can say. It should be, if you're going to do some kind of productionization, right? You are going to put this model into production, so it should be around 90% or more. Okay, that's a general concept. Clear?
90% or more.
Generally, generally, at least in my all the experience into this data science, right? We are following this, that if a model is 90% or more, we'll push
Mhm.
to production. Otherwise, we'll try to tune.
And
But
how
we'll
long
also
does
see.
it take to tune it? I mean, do you guys use this cross validation techniques or what?
Yeah, cross validation is one, but we also use hyperparameter tuning. Okay, so
Mhm.
generally, I
Grid
said
search
no.
or something like that.
Grid search is, CV or randomized search CV, right? We'll use that. Okay,
Okay. Yeah. Okay.
and even more, we'll also use this bagging and boosting techniques. It is generally used. Okay, that if your model is like, because we know that with the help of this, right, we can avoid these underfitting and overfitting, because this is one of the general question asked by stakeholders, that okay, what is the accuracy of your model? Even though
Hmm.
your accuracy is less than 95%, can we rely on this model?
Uh,
So then we have to explain the features, why this part. Okay,
okay.
so like this.
Do you guys even get to see which features, like after doing an ETL, say
Hmm.
you take the data from some source,
Hmm.
you have so many features, and
Yes,
do you guys even tell, like show it in a table that okay, final model will use these many features, and you can create uh, an automated process to supply us these data for like 24 hours or maybe 10 minutes or some continuous time period. You can share only these data, that model is good to go. Like, do you do that?
definitely. See, these features will come from the domain experts. Okay, and
Yes.
and after analyzing the data.
Mm.
So domain expert will tell me that out of 100 features, right, which 10 are important. Then
uh,
after analyzing that 10, maybe I can say no, no, the ninth and 10th is not important. Maybe eight are important. So what I'll do, I'll do the statistical test, right?
okay.
I'll
Yeah.
perform correlation, covariance checks, right? I will check the feature importance. Basically, we can see in the Python libraries also, we have option to see the feature
RF.
importance. Yeah.
Yeah.
So basically, you'll come to know which features are important, right? Which features are contributing how much towards the final model. That even that you can see. So we'll do
Mm.
that thing to know. And then out of that 10, out of top 5, 10, whatever we require, right? We'll take that.
Okay. And you guys get similar kind of data sets, or does it vary every with every project?
Depend on use case, what use case we're going to solve it. It differs every time.
Okay.
And even the volume changes with the time. So we have to retrain also.
Oh, okay. So
So
you guys are like real scientists, real heroes of the field. Yeah.
not real. I think we are still learning. That's why we have joined this course. But yeah, I can say we are doing quite a lot of things. Yeah, in this field. Yeah.
Nice. So I'm handing over to you now. I'm stopping this.
Sure, sure. So next, I will just explain the other part of ANN. Let me share my screen. I think we have taken half an hour to just for this, but I hope this is fruitful, right, guys?
Of
You
course.
Yes, yes, yes. Great discussion.
Yes, it
okay?
is good actually. Thanks.
Okay, no problem. So since I started last week, right? Let's see. Now I'll continue from there. I'll just give you a background in last in 1 minute. So basically, we talk about what is deep learning, why we use, okay, and then we also saw that what are the main parts in the deep learning, right? So out of that, right, we have something called ANN. Okay, ANN is called your artificial neural networks. And why the name given like this? Because it works kind of similar to the human brains, and human brains have neurons. So basically, whatever you do, right, a neuron will get activated for that purpose, and then it will say that what action you have to take. Let's say if somebody is putting a hot cup or let's say glass in your hand, okay, so that neuron will be getting activated, and then it will immediately pass the message to the brain that there is something hot, you remove it, okay, or you have to take action. So immediately, so the reaction will be in fraction of seconds, right, or maybe a microseconds. So this is that fast. So same kind of behavior is done by artificial neural network also. Now let's start with the next thing. So in artificial neural network, right, or ANN, we have majorly three parts. First is your input layers. I talked last time also. This is your hidden layer, and this is your output layer. Okay. So assume you are working in a regression problem. I'll just jump into the this part this way to explain. So let's say you are working in a use case where you have to predict the price of a house. What should be the price of a house? Correct. So let's say you have couple of features. Let's say I take these three features x1, x2, x3. Maybe you can understand is like area or locality is one of the feature. Second, you can understand the facilities given into that. Third, you can say like maybe number of rooms, right, in this. So these are three features. Now these features are given as an input to your artificial neural network. With each feature, there will be a weight assigned. W1, W2, and W3 are weights associated with each feature. Now that weights and the feature values, right, will passed here in the neurons. I have taken for simplicity, I have taken a one neuron, but it can be multiple neurons and multi-layer also. Okay. So this values and the weights will be passed here, and one activation function is applied on this neuron, and then whatever is the output, right, that output is passed to the next layer. But before that, there is another weight applied here with the result, whatever result we got it from here, and then that that value is passed here as an output. Okay, and then we will see and we'll compare that what is the output and whether it's correct or not, and then it will go and back and do a backward propagation. So what exactly happens here is when you pass these inputs, right, and the weights and inputs are summed up. Okay, so basically whatever weights you are passing, right, and weight whatever input you are passing, all get summed up here in this. So it is having two parts. I'm just shown here. So it is having just two parts. So the weights multiplied by your input plus weights multiplied by your this input, but weight multiplied by this input. So all three are done, and then there is a bias associated with that, and that task is done here. And once this is done, there is an activation function, something called as an activation function is applied. Okay, and this activation function is like this. So there can be multiple, there are multiple types of activation function. We'll read it later, but you just understand that there are two things happening into this neuron, and it will happen in all the neurons basically. Whenever whatever number of neurons is there, right, it will have that kind of functionality. So what I'm doing here, summation of all the weights and inputs plus biased, and then actually activation function is applied here. So these two things are applied here, and then whatever result will come, right, that result along with this weight will be performed multiplied basically, and then you will get the output here. And that how a basic neural network works. Any question till here? Just for the simplicity I have done this. Any question till here?
No.
Okay, good. So once this is performed, you get this output, right? Now this output, let's say if it is the case of regression, this output is compared with the actual values. So whatever actual values you have, it will be compared, and then if it is not very close to the actual, then what will happen? Again, a backward propagation will happen. So this is called forward propagation. Basically, you are going from input layer to the output layer. This is called forward propagation. Again, since the output is not very close to the real values because we are doing training, there is a backward propagation happen. So there will be one arrow from this layer to this layer, from output to again till here, till this width, and that is called your backward propagation. And this forward and backward propagation is called one epoch. So what is basically this will be performed. Now, once this epoch is performed, again it will go and check every time. Basically, it will go and check that how close your predicted value with the actuals, and based on the number of epochs you have chosen, because that value we have to mention into the code. What is the epochs we are going to use? That value will be that number of time it will run, and it will try to minimize the cost function or loss. In general terms, cost function or loss function is a function. Basically, it's a difference of your actual and predicted. So whatever is the difference of actual value and what is the predicted value, and whatever the difference is, right, it's called error. Or if it is one value, we call as a loss, and if it is multiple values, we call as a cost function. Okay. Now, what two operations we are doing is, one is your summation, one is your activation function. Now we have two types of, generally there are multiple activation functions I can say, but I'm taking two here. So there are two functions which most of the time we use is sigmoid or ReLU. These are the activation function we use generally. Can anyone tell me where we have seen this sigmoid? Any place we have already learned it somewhere? Anyone know?
Logistics regression, yes.
Yes, correct. So in logistic regression, we have already learned that how sigmoid function works. The purpose of sigmoid is it will convert your all the values between 0 and 1. Okay. So whatever, let's say you are seeing the formula, right? 1 divided by 1 plus e minus power y, right? Y is your this. So whatever, let's say you did some this calculation, this, you got some value. Okay. Now if you pass this here, right, it will convert that into 0 and 1. Okay. And that's how, if you see the graph of the sigmoid function, right, it looks like this, starting from 0 threshold. Let's say assume 0.5 is our threshold, so it will go to here. So it is having shape like a S kind of shape. Okay.
So even if my training, sorry, the transformation to find the suitable coefficients is
Hmm.
linear,
Hmm.
the activations and the optimization functions are again non-linear, rather say exponential. Is that so? I mean, um, is it not the again? Is it not going against the entire philosophy that we need to get everything in the order of big O of n or big O of n log n? I mean, this is just a thing that was confusing me for a long time now. That okay, we are trying to use the data set to predict labels, and
Hmm.
all those transformations are linear: w1
Hmm.
x1, w2 x2. Okay,
Hmm.
except for the fact that we are using sometimes polynomial basis function or radial basis function. That is a separate
Hmm.
thing. I'm not what I'm talking about. But these activation functions or the optimization functions all are using some sort of exponential or polynomial order to compute the error. So does it not go against the entire logic that yes, we want to use it in the order of n or on the order of n log n, you know, from the very beginning in the asymptotic relationships we were reading that every algorithm for np region has to be an np sorry, a p order or maybe an np complete, right? There are two two sets of the problems like SAT problems and sorting problem, or say merging problem, all these search problems, they had to be in like of the order of polynomial.
Maybe not that much clear. This question is not clear to me, but see the purpose. I'll tell you here. What is the purpose here? So what happens, right? In this layer, right? What you are doing? You are doing going to do, let's say, classification or regression. Okay. Generally,
Mm,
these kind of things happen here. Okay.
yeah.
So in case of classification, okay, mostly used for classifier, I mentioned, right? So
Mm,
you need a class, right? Let's say if in a binary classification, what happens? We have two classes, zero, one, yes, no, right?
yes.
Now, why we use mostly here is like, let's say it has performed some calculation and you have got some value. Now, how will you classify? So what it does is it will convert your value into that number between 0 and 1, and internally it takes, like if it is less than 0.5, it's the basic threshold value, we call it a 0, and then it will classify as a 0 or no, whatever, and if it is more than
Mm,
0.5, we say it's a 1. So the one thing which you are talking, mostly what I understood is like it's for the timing, how much it is taking for the running, right, based on the
yeah, because
asymmetric
you said
nostration and
no,
all, right?
like feed forward and back propagation is one epoch.
Hmm.
So while feed forward, it's okay. We are taking a linear time. While back
Hmm.
propagating, how much time will we take if because of these functions? Even in feed forward, also activation function is in feed forward. So how much time does it take to compute these activation functions?
See, it depends. It depends. This feed, because it this back propagation and forward propagation, right? It does not happen automatically, unlimited. Okay, it depends on how much you are giving input. So based on your input size, right? Let's say we call it as the epochs. Let's say if you've given 10 epoch, so it will
Mm.
only go 10 times. Okay, and whatever value is giving, right? Whatever, it will give you as a final result.
But
So, hmm,
you guys are handling so many, well, like you guys are actually handling big real time data.
hmm,
So I was just wondering, like, if you are going to train something like a neural network,
hmm.
training so many neural networks
Yes,
based
yes.
on it will take like many days, so, say days.
Depends. See, depends on the data set, like how large it is. I have not got any data set which has trained for days. Maybe I'm not used to work on those use cases, but definitely it takes like a couple of hours. Like I have worked where it executed for 10 to 12 hours also. Okay, it was running for almost whole night to train. So it all depends on this thing, right?
Also, can I, Anjani, can I also, Prasoon, what happens is after you train it, it does not get trained every day, right? So retraining happens only when there is a trigger for retraining.
Correct, correct.
Sorry,
Yes.
this come as a shocking to me. What was that? Retraining.
Yes.
Is
So
this not,
retraining, yeah.
how does that happen? I mean, does it not? What I thought was maybe like we had a model and we can only train it once, like the
Have we
base.
trained? Yes,
See,
you're right.
generally we train only once until the data is changed. Okay, so let's say you have a billion of records. Okay, now for those billions of record you have decided to go with the neural networks because you think that it is going to be best suited for that you use case as well as the data. You
Okay.
started training, it takes like, let's say, 10 hours. So in
Uh,
10 hours your model is able to learn the all the details from the data. Now your model is ready. Now with this model, you have going and do the prediction. So once this training happened, right, it will not take this 10 hours for prediction. It will do immediately. Okay. Now, if your, let's say, 10%, 15% data changed, not few records. Okay,
okay.
some percentage because you are talking about billions. Then
Uh,
what we'll do, we'll plan a retraining strategy where we'll think, okay, maybe after, let's say, 2 weeks or let's say one month, my data
mhm.
is changing in this percentage. So I'll retrain this model.
Okay.
Retraining means same step will have performed, okay, one more time to see
Mm,
how it is performing, and we'll get some result. Let's say with the retraining, right, we got that, okay, earlier it was performing good, but now accuracy has reduced drastically. Then
okay.
again we have to see that what has changed. Okay, and then
It is
again,
basically called concept drift.
hmm.
Yeah.
So
Did. Data drift is also part of it.
And if the
So
stakeholder are not very thorough with this concept, then they might piss off on this. Like, what kind of model have we deployed on
no,
production?
no, they know, though they know very well. They
Your model prediction will, your error rate will start shooting up, no? So they would themselves would ask you, so what is happening with the model? Why
see
don't you retrain?
generally either you will tell that based on the data, right, that we require retraining after this period of time based on the data, or even the stakeholders, because the stakeholders who are working into this domain, right, they have a idea that there is a part of retraining also. There is a part where model will not perform good also based on the data changes. Okay, so they know very well. Okay, so based on that we'll decide a date that okay, in this date, or let's say frequency, right, this frequency,
Okay,
this will change. Okay,
all right, all right.
and we do the retraining.
Uh, and what about that? If you're training it for hours, say,
Hmm.
uh, and the model turns out to be like overfitted or maybe underfitted, what do you
Hmm.
guys do? I mean, like, do you have to like, of course you guys are using cloud, and
Hmm.
every source that you take for training
Hmm.
uses
Hmm.
some cost to the company.
Yes.
So before proposing that, okay, sir, I'm going to propose this model for training, do you
Hmm.
guys even make some recommendation that this will cost this much computational hours and I need an approval for this? I'm like, does this happen?
No,
Like that?
generally, let's see. In my case, that we're using Microsoft Azure. Okay, so we generally don't do this. Okay, they know that if machine learning models are being created, it will require retraining also, and they are fine with that. That okay, this will require retraining, and we will be doing this. Okay,
Okay.
we do not require any kind of approval, because approval means you are asking like that there is a, let's say, a fire, and you're asking somebody that shall I go and just start watering with this because there's a fire, so you will
Uh,
start reacting right immediately. Okay.
uh-huh.
So this is that case, and how it works is, once you create a model, right, there is something
Mm,
called pickle file. Okay,
yeah.
so you'll create a pickle file. This file is like a streams of byte stored into a file, and that
Mm,
will have all the insight about the data, and you'll
mm,
keep running your model prediction, and side by side you will be retraining. So the retraining, so basically we have a concept of versioning, if you know the ML ops, right, where it will take care of all the versioning part also. So
I
ML
don't
ops we
have
generally
any
use.
idea about MLOps. I've heard about it. I was very fascinated, but I don't have any idea how it works.
Yeah, even we have just started few days, a few weeks back actually in my project, but we have a concept where it will take care of all the retraining part and everything. So all the versions will be stored here, right, and it will not impact until you are going to change or you are going to flush it out. Okay, so the previous versions will be already there. So it's not like if there is an issue with the data or if data is changed, the immediately it will stop working, and until you will train it will not work, right? It's not the case.
Okay, understood.
So once this is happened, right? So this is one function mostly
Mm,
used with your classifier. The another one, which is more famous, okay, it is called ReLU. Okay, so ReLU is used for mostly regression. How it works is, this is the formula. So basically, what it takes is max of y comma zero, means if the value is less than zero, okay,
mm,
it will take the max value basically. So if it is minus one, minus two, right, so it will take this,
zero.
else this.
Mm,
Okay, so your value means if your value, if your y value is negative,
mm,
output will be zero. If your value is not negative, it is the value itself. So basically like this. So
yeah.
if it is zero or less than anything this side, right, it is all zero. If it is one, output is one. So if it is x and y, suppose this is x and this is y. So if your x is one, output is one, x is two. So this kind of is used in regression problems. So mostly, and this is applied in the last layer. Okay, so basically this layer. Okay,
Okay.
so I think I have code, but this is a company's thing, so I'm not showing it. But we have implemented something like that. So basically, what you do is, right, you will create an input layer, one input layer. You will define your activation function. You will define your all the what matrix you're going to use, right, for to evaluate, right, and then once it's done, you will create a number of hidden layers. Maybe it may be one, two, three, four, five, depend on the use case, and then there will be a final output layer.
Okay.
Okay, and once it is done, then you have to mention in the last step, right? That with what metrics you are going to evaluate, and then how many number of epochs you wanted to execute. So as I said, right, let's say if I define 500 or 1000, so 500 time this forward and backward question will happen, and then you will get a result. Okay,
Hmm.
and so that's what is generally happen, and you'll finally get this output. Okay, so generally when the data is heavy, right, data is more, we you go for ANN. Otherwise, we try with other models, ML models. Okay,
Okay.
data is heavy, or maybe we do not want it to perform much feature engineering part, right? So it takes care of that internally. Okay,
Okay.
yeah.
So, do we use FCNN in these cases when we don't want to like work much on feature engineering or on identifying the important features? Can
What
we
is
use
FCN?
like the one which we are discussing, fully connected neural network?
Acha, okay.
Do we use that, or like yeah, we use a CNN, or because there are so many variants of this neural networks, no?
Yeah, see, the purpose of CNN is different. This is for handling your, you can say mostly the data which is related with the, I can say, let's say you wanted to do prediction for, let's say for maybe some kind of prediction use case or classification use case, right? But let's
Mm.
say if you wanted to handling with planning to handle something called images or videos, right? Then you will go for the CNN. Okay, so the
Yes,
purpose
that's
is different basically. Yeah.
um, so we don't usually go outside the use case, like for any other objects detection or real time video detection. We don't go for CNN. We go for
No, no.
image.
For image videos, right? We'll go for CNN. For other use cases, right? We'll use NN. Like if you wanted to perform, let's say I wanted to perform regression only. Okay,
Okay. Uh,
regression use case, but I don't want to use linear regression. I wanted to use something different. So what I can do, what option I have, I can use this also. Okay, where I know the data is more, and I do
okay.
not want to perform much feature engineering part here. So
Okay.
this can be taken care in this NN. Okay,
Yeah. Okay. Right.
but in CNN also it is having kind of same architecture. Only there will be a convolutional layer is added here. So that layer will help us to identify the edges of the object, and then you will be able to classify whether it's a particular object, let's like cat or dog or something like that, maybe man,
Mhm.
woman, right? Like that.
That
So
also has like dropout layers and
yes,
everything.
yes, yes, yes. Same architecture. Only one label will be added in CNN. Okay.
Okay.
We'll talk more. Okay, definitely.
Yeah, of course. Yeah.
So, uh, any question in this, guys? Like any confusion? What is happening? Why it is happening?
I just wanted to like if you can show. I don't know if Adobe Acrobat you have that pen option. Can you show some intuition like how the back propagation works? Because feed forward is understood, like how it will start with a random weight and then it will start to iterate. But how it will iterate on from the error side to the weight side? Uh,
I got a point. I don't have pen actually, but so basically what happened? No, once this is performed, right, and when the activation is applied, no,
mhm.
so then we have some mathematic part. What I'll do, maybe I'll create an image and I'll do some mathematics and then show you guys with the numbers. Okay, what how it is happening next time.
Okay, but if you can find any similar internet resource also, that also you can share, because I
Uh,
find
let's
it
see.
very easy. Like if there is an
Uh,
internet resource like image,
back.
all we need is a good keyword to find that image.
Uh, something like this. Actually, calculation they might have not done here. No, that's not
Not exactly calculation. Calculation does help, but if there is an like
something like this. Suppose this is
yeah,
a. It's not clear. somebody has drawn. See, even somebody has drawn like this. So this is input layer. This
You
is
need to
hidden
share
layer.
that screen. You need to share that screen. You are on Adobe right now. I mean, like you have shared particular window, right?
One second. One second. Now is it visible?
Yeah, here it
Okay.
is.
So somebody has drawn this thing. So see, I was showing with a simple neural network, right? Now it is only one hidden layer only, but you can see multiple neurons, one, two, three, right? And
Yeah.
this weights, right?
Mm,
And the input is associated with each. So if you see here,
mm,
this x1 is associated with your z1 also, z z also, and zp also, right?
correct.
And there
Yes.
is a different weights assigned with each connection.
Yeah.
So, okay, so once this connects here, right, with z1, so this x1 multiplied by the weights, okay, plus bias is performed here in each hidden layer neuron, and then activation function is applied here, and then you will see the output which will be multiplied with this. So back propagation thing, I'm just checking like this. See, so you see here, this is your output, and once this output is here at thrown
This
to
is I
this,
have like the predicted value, right?
so it will be compared like how what is the difference of actual predictor, and if with this difference value, right, this will
Mm.
go back like this. Okay, so all
Go.
these weights will
Mm.
be updated. So all the weight updation will happen in the back propagation. So let's say you started with say some weight. So that weight will be updated based on the you have to something called as this kind of formula is applied. Okay. So
Mm-hmm.
derivatives basically is calculated and this kind of formula is applied and then the weights are updated because see the final thing is that we wanted the right value of coefficients or weights, right?
Yes, correct.
Because
Yes.
inputs is same. What you're
Yes.
playing with is the coefficients or the weights, right? So
Okay.
if you get the right weight, you will have the right number, which will be very close to the real values. Okay, and that's how you make your training. So this kind of formulas are applied, and
Why
then weights are
I
up.
keep asking this question? No? Because
Hmm,
in case of normal, like the ML questions where we were
hmm.
like
No, no,
optimizing
that
cost
that
function.
that I, that I'll take care. I know that. Yeah. So
Uh,
next session, no, I will tell how these weights are getting updated
okay.
and complete this picture. Okay.
Okay.
Then you will know that okay with this propagation net these weights are getting updated. Don't worry. I'll
Okay.
take this week only. Last week I didn't get time actually for the second session. But this
Yeah.
week at least we'll complete this AN part where we'll talk about how the back propagation is happening, how the weights are getting updated, okay,
Mhm.
how derivatives is getting calculated, okay, all these things. Okay.
And one more thing, I mean, have you heard of this 8-bit machine theory in like deep learning? Just because, I will tell you the notion. Since in ML and artificial intelligence on the whole,
Mm,
they don't require precision. Like they are into the generalization of the prediction. So they are saying that the community, the computer scientist community, is
mm.
like pitching to go from 64-bit precision to 8-bit precision to 8-bit machines so that they get more memory to work on those calculations instead of 64-bit. I mean, like, have you heard of these kind of things? And uh,
No, frankly speaking, no, I have not. No, maybe people who are in research, right? They might have known. Okay.
okay. Okay.
8-bit, 64-bit, I have heard like, but what exactly it is, how and where we are using it, I've not
Okay.
used. Yeah, yeah.
Okay. Okay. Nice.
But definitely, I'll explore it. Use.
Yeah, sure. I'll try to send that article. I read it somewhere. I keep on opening these tabs, and there are like so many tabs over there. At
Mhm.
once, I have to close it. I'll search for the history and I'll share it in the group maybe today only.
Sure, 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 sure. Okay. So that's all, guys, for today. Two concepts we got to know today. Basically, bias variance trade-off and it is linked with your overfitting and underfitting. And then we have seen the neural network and how it works with the simple neural network. Okay, next week we'll see how the weights are getting updated, so that we'll have a clearer idea that what is happening, because these kind of questions are coming into exam, right? So we'll see that. Okay. Yes, Manoj, thank you so much, guys. Okay, so
Thank
how
you.
many people are there? Only few. Okay.
There will be many in the recording session once it is uploaded.
Okay. I was thinking like if more people add, maybe we can change the timings, because if more people can join, it is useful. Even people can give their input, right? So even it will be helpful for me also, that what I don't know and what should I focus on, or maybe if I
Yeah,
have any, right? So.
but we unfortunately we don't get time other than 9 to 10 or 9 to 11. Say even now I'm not. Today I'm fasting, but this time if I don't get the dinner, I will like skip the
Hmm.
family dinner time. So like
Mm-hmm.
mm, the same for many people, I guess. You know? So
Okay.
just
Okay.
yeah. And Manoj, thank you so much. You are conducting these sessions. This is really helpful.
Yeah, Manoj is super active, I think, in this.
Even came up with this tutors video as well. This is really helpful. You have shared tutors videos as well, no? That's very good.
Yeah, this session is very helpful actually. Thanks, Manoj. Thanks, Anjani.
Yeah, thank you, guys. Yeah, thank you. Okay. Bye bye. Bye. Good night.
Yeah.
Thank you all. Thanks, Anjali.